things that we're looking forward to is 40 gig E and 100 gig E, especially 100 gig E. Doesn't seem like, we always talk about it in the context of long haul environment because that's where we see the first applications. But if you can get to a point where you can aggregate this, say below at a metropolitan area, a New York City kind of area, then even 100 gig E starts to come into play, where those ports are assumed to be not only lower cost for as opposed to 100 of them, but you can get them into a switch, into these very large router ports where you'd be physically constrained, where you can't get enough I/O, and also the backplane slots. I don't know if a lot of folks have looked at the router ports today. You can stack switches underneath it to do the aggregation, but you can't go directly into a router port anymore and get full utilization at gig E. It's even worse with the fast 100s. But going forward, we see that problem getting even worse, at least with the number of boxes that we look at, the big iron, if you want to call it that way, the CRSs or the MX960s, and that kind of machine sitting in the core of your network is going to, in order to get the utilization up, the port speeds have to be really high. You can't rely on a lot of fan-in, so you got to put something underneath it. Well, that something underneath it is a box, at least in our context, that we already have there, because it's the same transport platform that's providing the wavelength services and the MSPP type services, TDM type services that we've got in place. What we're trying to do is leverage that same piece of hardware. Perhaps sometimes it's sitting as a standalone box that's only performing this layer 2 aggregation, as we're calling it, but it would be this conversion or fan-in from a lot of native Ethernet going to very large pipes, or the conversion as it would convert it from Ethernet over SONET. And it may be totally dedicated for that function, but it's the exact same box, which means that you've got only one part number effectively, or one platform that you had to get your back office systems to support, that you had to get all of your system integration and testing done on, that you had to work with one supplier with, as opposed to multiple suppliers that you would have to do if you tried to scatter that out the way we used to do it. So the point of this one was to show that the savings, if you do this aggregation, it's pretty directly related. Again, we did it generically because you got to look at how much you're paying for router ports or switch ports that you're going to connect to versus the transport layer, and then that's going to be somewhat different for every carrier. But the point being that you will save those ports, and if you do that, the cost will track accordingly. We also did a recent proof of concept testing here up in one of our labs. So this was lab testing, but it was to really lay this out, because if I would have spoke a year ago at this same event, I would have said, well, you know what, COE is the kind of thing we want, but it's just not quite there yet. And the bad thing about videotaping, they'll remind me of this stuff later. Last year you said, and the truth was we did. Even up for the last couple of years, we've been asked the question, why haven't you used a lot of COE? It's on the books, MEF supports it, you've got EPL type services, you've got a lot of Ethernet in the network, why don't you use this kind of device? And it was, the same old problems, the fault propagation, performance monitoring, reliability of some of the equipment, especially vendor interoperability, has been a real challenge up until this time frame. That's why we did it, in this case, this isn't all the big boxes are Fujitsu 9500, but not all of them are directly related to our Fujitsu products in this case. The point being that interoperability is, we're finally getting to a point where you can do interoperability. You can build a real network out of it. Every supplier would like to say, well, let me build your entire network, and that's feasible for small carriers. It's just not feasible in a large network, large carrier network. So you really got to have multiple suppliers, and in order to take advantage of something new like COE, it has to be interoperable. You have to be able to create that large pipe and hand it off and have the link ag work between the boxes and have the PMs propagate, or alarms propagate, and the PMs that you can pull. So what we did was create a relatively complex network and ran SONET and Ethernet over the same, carrying video and carrying a test set. The video is always nice to show the executives, but you got to have the test sets there for all the engineers in the room to say, well, exactly what was the latency and how did it compare? And that's what we were trying to do with this proof of concept, was to show that latency is identical or nearly identical in the same ballpark as Ethernet over SONET. Protection switching times are again identical or below 50 milliseconds, so that they don't necessarily blow up the network. It doesn't mess up our SLAs the way we have them today. It doesn't mess up our customer perception on how we're doing this, because again, we want the service to look identical to our end user. he's used to seeing a Ethernet service from us as Ethernet over SONET. It has to be of that same caliber in order to get away with selling him another service. Now, granted, our infrastructure cost goes down. All the stuff that Ralph talked about, you're improving the granularity, therefore you're improving utilization on that transport infrastructure. So the benefit, if you will, comes to the carrier, but that experience has to be identical, if not better, to the end user, or else you just can't get away with it. You can't sell it to the guy who's, even if it's an internal customer, he's saying, no, wait a minute, I know a little bit about Ethernet and I don't like it. I'll like it at the end user, on my access maybe, but I'm not going to allow you to do it on the transport infrastructure. And that's what proof of concepts like this are doing. And I think the reason that we wanted to, certainly why we did it was to side by side with SONET, EOS, was to show that we're finally getting there. We're finally getting to a point where it not only works, but it works in a reliable fashion with GA quality products. So I think that was all we had today, and we'd like to take a few questions if anybody had any. Or we'll keep talking and you'll have to listen to us some more.
Hi, Terry Michaud from Verizon. And today we get a lot of requests from wireless carriers for 1 gig Ethernet at a cell site. Are we there yet? And if yes, then are we going to be ready for 10 gig next year? As we, today over the last couple of days, we've heard a lot about the data growth. And 1 gig is not going to handle it in downtown New York very long. So even when we get there, we know we're going to have to go beyond that. So where do you guys see that going?
Yeah, so I think one of the, to put that into context, a lot of times we light up a tower, and the commitment from the company is to light 90+% of the towers out there and in region, where we're the carrier, dominant carrier. A lot of times there's more than one wireless carrier per cell tower. And that's where you get really big bandwidths, even ahead of individuals. You would always say, does Verizon Wireless or AT&T Wireless or T-Mobile, any of these guys need that much bandwidth? Maybe not individually, but aggregated they sure do. And that's why today we generally treat all of those towers like we would a small enterprise business. So we put a SONET box out there, and then we aggregate the Ethernet underneath that. And the method going forward would work exactly the same way. Only again having more granularity and the same or better utilization of the underlying infrastructure. But there's no reason why that same, as we pointed out here today, works at 10 gig, works at 40 gig, would work at 100 gig. That Ethernet over fiber, that would be the only thing that Ralph said. I would say generally we call that Ethernet over OTN. So as soon as it's wrapped up, as soon as it's a full container that you're going to transport a long period of distance, you would wrap it into an OTN container so that you get all the benefits of forward error correction. Again, if it's up to 10 gig level, so this would be your, the only caveat I would add there. Once you get to 10 gig, it's always wrapped up in an ODU2 wrapper so that you get forward error correction and you get all of the out-of-band kind of performance monitoring and control that you would have with an ODU wrapper. Ralph, anything to add?
Yeah, I would just second that on the OTN side, just because SONET just goes up to 10 gig, right? So when you want to backhaul it beyond that, especially if it's over a longer distance, then yeah, you'd want to start using OTN for that. But I think just to also state what Glenn said, connection-oriented Ethernet technology, again, it's layer 1 agnostic, whether it's over OTN or SONET, number one, and number two is it's really speed independent, right? I mean, it's just the way you would build your network, the way you'd protect your network. It doesn't matter whether it's gig, 10 gig, 40 gig, 100 gig, doesn't matter. The other piece too is, I think, getting back one of the points Glenn made about having multiple operators at a tower, right? So when you're doing backhaul, when you're at the tower, you want to get everybody in the tower, right? So you're going to design that, design your backhaul to accommodate all those, and some of the towers today, are on the order of like 300 megabits per second per tower, and they're kind of looking ahead towards LTE, which is why they're putting that bigger amount in there to look at LTE, because most of the 3G traffic, except in very large metropolitan areas, which are probably more the exception, but if you looked at the general rule, even for high bandwidth 3G and then moving to LTE services, something like 300 megabits per second, roughly that is pretty good amount of bandwidth, but that's much higher, than what you would have for 3G backhaul today. In many cases, it would be much lower amount. So I think the build out is already getting there. It's already going hundreds of megabits per second. Will go to a gig, for a lot of the for those high density areas, go to gig, but then eventually 10 gig, and especially if you have multiple operators on the tower, which you will have, 10 gigs right around the corner.
Yeah, the only thing I'd add is that they also like to do that over time, right? They don't come to us day one and they'll say, this is my expectation perhaps, which means we lay out a lot of extra capital betting on the come line, if you will, and here we'd rather grow that out as we need it. And there's one thing nice about Ethernet is that the incrementing, decrementing the bandwidth is a whole lot cleaner in service than the previous Sonnet version, than using, say, VCAT and LCAS has been in the past. So there are some inherent benefits from a right-sizing that pipe and incrementing or decrementing it. I've never seen anybody decrement one, but always increasing that, and they can do it in more granular steps than they perhaps could have in a Sonnet environment. Again, this is assuming all the infrastructure's in place, and in many cases that's not the case yet. I don't want to mislead anybody, but it is something that has a lot of merit going forward. And wireless backhaul is a perfect example, although you can point to the enterprise guys and say the exact same thing, or even to a lot of other service types that are migrating away from traditional TDM to giving us more Ethernet based.
Yeah, I think just to add to that, so along those lines, one of the platforms that Fujitsu has, the FlashWave CDS product, is meant exactly for that, where the same platform, once it gets deployed, you can have gigi to the base stations, but then you can also have 10 gigi in the exact same platform. Because once you think about it, when you deploy to an outside plant cabinet at a cell tower, the real estate is not only precious, but there's not a lot of churn. You want the decisions that are made by the wireless provider in terms of when they go to backhaul, they want to look at longevity, right? Maybe it's a 3-year contract. So whatever gets deployed out there, both as a backhaul service, but including the equipment, needs to be able to evolve as the needs of that wireless operator evolve, because you can't just go out there, after a year or whatever, rip everything out and try to re-engineer everything in, because not only is it, time, but cost and all operations have to be rejigged and everything. So that's a really important, and as Glenn pointed out, you need to have sort of this evolutionary path in place for the backhaul network, as these, who knows, there'll be a 5G service a couple of years from now, right, or something like that. So even though LTE is just starting to come out.